Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue with our discussion of Java native interface, and we are going to look at a very important topic of primitive arrays, how to go from primitive arrays in Java to primitive arrays in C++ and vice versa. And the important thing is that arrays of primitive types in C++ are completely different from Java. So arrays in Java, like one-dimensional array, is just an object like any other object. But an array in C++, a one-dimensional array, is a special thing. It's a chunk of memory that is tightly located together, right? All the elements of the memory are tightly together. We said that the primitive types like double maps to jdouble, float to jfloat, int to jint, and these are all signed numbers. But then a double array doesn't maps to a jdouble square bracket open and close. It doesn't do that. So it maps to a j object, and the j object has a type of jdouble array. So if you look at the JNI.h, you see that we have a j object, and all the subtypes of the objects are other types objects. So jdouble array is a subtype of the j object. All right. So float array from Java maps to jfloat array. Int array maps to jint array. All right. So in general, any type that we have in Java that we use that we create a one-dimensional array maps to j type and array word, right? And these are all primitive types, so we cannot have a string array. A string array doesn't map to j string array. It maps to j object array, and that's something we look at after we look at these primitive arrays. So for primitive arrays, it's j, the name of the type, and then array. And then all these types are subtypes of the j object. So the j object has a role in JNI as the object, as the same role that object has in Java. So j object is the super type of any other subtype of objects that we use in JNI. And then in order to basically convert a C++ array to a Java array or a jdouble array, for example, we have to use this convenient class called JNI environment, and use one of the methods or functions inside this basically class. So we need to use a JNI environment to create these arrays and fill them up with the values from Java, or vice versa. So step one, create a new jdouble array. So obviously I'm using an example of double, but it just applies to also jfloat, jint, jbyte, jshort, anything else, or any primitive array in Java and then its corresponding object type in C++. So create a new jdouble array. Jdouble array, I call it jarray, and I use the environment, and this is a pointer, so it's not the basically the name of the object, it's the pointer to the object. So instead of dot, we use the arrow operator to access the methods inside the class, such that this this variable is the pointer to the class. And then we call this environment. Basically we are asking Java, saying that okay, Java, in C++, create a double array for me. So environment new double array, and we need to specify the length of the array, just like in Java when we create a double array equals new double, we have to also specify the length. So from the environment we use a new double array and len, and this len is just a jint, right? So we pass in the length of the array, and this returns a j object, which is the basically returns a jdouble array, which is a subtype of a j object. All right, so jdouble array. And now we created the array, we need to fill it up with C++ array. So let's say I create a C++ array, jdouble, or just the raw type double. I always prefer to use the JNI types, jdouble c array. So this creates a C++ array of type jdouble, which is the same as double, and I'm initialize it to 1.1, 2.2, 3.3, and 4.4. And note that here when we use this notation, this C array variable holds the address. Basically C array is the pointer to the beginning of the array. Again, this is another difference between Java and C++. This C array is a variable that is basically a pointer and points to the first element, the address of the, basically it holds the address of the first element of the array. And now we have our j array created J double array, we have the C++ array, and all we need to do is fill this J double array with the values of this C array. For this, we use another method from environment, the JNI environment, which is called set double array region. Set double array region means, okay, take this double array from C++ and copy it into this J double array, Java array, from index 0. So we specify the start index and the length, the number of elements that are to be copied from the start index. So typically if the lengths are the same, then you say, okay, from index 0 and the length len, right? So the first element of this set double array region is the double array, is the Java array, J double array or J int array, whatever. And then the next element is the index from which we are going to copy the elements from C array, and then the length, or basically the number of elements to be copied from the start index, and then the C array, the actual C++ array. All right. And if you want to do the opposite, basically if you want to copy, so here with this set double array region, we are copying from C++ array to the Java array. If we want to do the opposite, we want to copy from J double array, from Java array to C++ array, we use, instead of set, we use get double array region. So basically it tells Java, okay, get the array, get the values of this Java array from memory and then copy them into this C array. And again, the first item is the Java array, the second item is the start index, the third item is the number of elements in the array to be copied, and the fourth index is the C++ array. All right, so it's very easy. If we want to just copy from Java to C++, we don't need to create a new array. We create a C++ array and use the get double array region. If we want to copy from C++ to Java array, we have to first create the Java array and then use the set double array region. All right, so let's head to Eclipse. I'm going to create a new package called test5, and then I'm going to create a class called test array, the test primitive arrays. Okay, so what do we want to do? The first thing I want to do, let's say number one, basically create a Java array in C++ and return it to Java and return to Java. So let's say I want to let's say I want to create a method public native double array len space, and then double start, double end, and then double or int, basically number of points. So this len space takes the start number and end number and creates basically n equally spaced values. So if I say len space from 0 to 5 with 5 values, so basically I have to create a delta x first, which is 5 end minus start divided by basically 4, right? And then 0, then the array should be 0, 0 plus delta x, 0 plus 2 delta x, 0 plus 3 delta x, and 0 plus 4 delta x. All right, that's why this 4 is the 1 unit less than the number of arrays, because the index starts from 0, right? So basically the last element is first element, which is start, plus the length of the array, which is num minus 1 times the delta x. So delta x should be end minus start divided by num minus 1. All right, so we want to do this len space, so it's a native, so we pass in this 2 double numbers and 1 int number. These are primitive types, so we pass these primitive types to C++, and we want the C++ to give us back a Java double array. So let's see how this works. So I'm going to select this Java file and then run the Java edge. to get the header file, and then I'm going to create another compilation unit or CPP source file. Let's call this primitive arrays dot cpp, and I need to include this header file first. So relative path header, and then test primitive arrays, and then copy and paste this one here, and then environment pointer, let's call it environment, j object test primitive array, just the object. J double is start, and then j double end, and j int is num. All right, so what do I need to do? I know that the number of elements is num, so I'm going to create a j double, let's call this c array, and then the length is num. Okay, and then I'm going to say that basically create a j double dx equals end minus start divided by num minus 1. Okay, so this is our delta x, and then for int I equals 0, I less than num I plus plus. Again, these are very similar syntax to Java. That's because Java was written to be very familiar, basically very similar to C++. And that's a very nice benefit, because if you're familiar with the Java syntax, writing the C++, at least the basic syntax of the C++ is almost exactly identical to Java. So we want the C array element I to be basically a start plus I times or dx, or I times dx, and we guarantee that the endpoint, the last value, which is num minus 1, is exactly the end as we expect. All right, so we created the C++ array, we fill it up, and now create Java array. So I have to use j double array. J array is environment, and then I cannot use dot. And C++ basically Eclipse IDE already converts it to arrow operator, not a dot operator, because this is a pointer. We can use this arrow and then say new double array, and then the length is basically num, right? We have num, basically this num. And then all I want to do is copy this C array into this Java array. So I say environment pointer, and then set double array region. J array from index 0, length is, or the number of elements is num, and then C array is C array, and then return this J double array, J array. Okay. So we create the C++ array, create a C++ array, and then fill it up with the values, and then use the environment pointer with the arrow operator, new double array, to ask JVM to create a double array, and then we ask JVM again to basically fill it up with the values of the C array. Now I typically use environment, but if you want to, you can also use JVM here, because it's just the name of the variable. So let's compile this. Compiles fine, and then copy and paste this library to our Java project. Go back to our Java project, and then let's create a main method, and then instantiate this class test primitive arrays. Test is new test primitive arrays, and then basically double result is test.line space from 0 to 5, let's say 5 elements, and then sys out. So if I return basically if I just sys out the result, this is an object, right? Double array is an object, so it returns the hash code. So before doing that, let me just also load the dynamic library, system.load library, and again we drop the lib from the beginning. So if I zoom in, we drop the lib from the beginning and then the dilib from the end, so we don't include the extension native C. So if we use the system.load instead of system.load library, then we have to passing the the absolute path to this file, including the full name of the file. But it's more convenient to use the load library. So if I run this, I get the hash code. Basically, this returns the hash code. The type, which is a double array, a square bracket means array, the type is double, and then the hash. This is basically the hash code, which by default, I believe it's the hex representation of the memory address. But it's basically the hex representation of the hash code. Hash code is an integer. This is the hex representation. But what we want to actually print the values of this. So we use the built-in arrays utility class in Java, and then say a string to a string, basically arrays to a string, and then double type result. So this basically iterates through the array and then invokes the toString over on each element of the array. So linspace, as you can see, works. We expect delta x to be 1/4, which is 0.25, and then 0, actually 5/4, which is 1.25. So our delta x is 5/4, which is 1.25. And then we start from the first element and then add it to the element until we get there. Obviously, we can increase, let's say, to 10 elements. Still works fine. We have 10 elements from the start, which is 0, to the last, which is 5. All right, let's go back to 5. So this is an example of how we can create an array, Java array in C++, and then return it back to Java. And the way we do it, we use this JDouble array and use the environment pointer to create a new double array, and then we have to fill it up with some elements from a C++ array. Okay. Now there are a few things, side notes here. So I guess side note number 1, if you're familiar with so let's call this side note number 1. All right, if you are familiar with the pointers and how they work, instead of using the array notation here, which is a familiar notation, especially coming from Java, you can use pointer notation, pointer math, or pointer notation. Remember, pointer is an integer. It is a 4-byte integer number, which is the address of the memory, right? And a pointer has based on the type, which is a JDouble. C++ knows that if I increment this pointer by 1, it has to go up basically some number of bytes depending on the size of this double. Double is 8 bytes, 64 bits, so it has to go 8 bytes in the memory. So I can say carray plus I, okay? But then I want to set the value, so this increments the pointer by I. So it goes to the next element. But if I want to assign the value, I have to dereference it, a star, and then set it to start plus I times dx. So pointer math means if I say the carray plus 1, it already progresses 8 bytes because JDouble, it knows the type of the array, which is the double, right? 8 bytes. So it progresses 8 bytes and points to the next element. And then I have to dereference it with the star operator to access the value of the memory location. All right, the value of the memory location. So this is the memory address being incremented, and then we dereference it and then assign the value to the value of the memory location. So this should also work fine. Let's compile it. Compile fine, and then copy and paste. Actually, I didn't save this, so let's save this and compile it again. Compile fine, the dynamic library was generated, copy and paste, and we expect our Java file to just work as before, which is the same. Okay, so if you're more comfortable with pointer math, you can use that, but coming from Java side, it's always easier to use this array math instead of. And again, this square bracket I is nothing but an operator. When it acts on a pointer, it basically it does the same thing, right? So this is a sugar syntax or something like that. So the same thing here, instead of using arrow operator on the pointer, we can basically dereference the pointer first and use the more familiar notation of the dot operator if you are again coming from the Java side. So if I want to use the dot operator, basically treat this environment as a object, which is more familiar in Java, I have to dereference it first. So star environment, it dereferences it. Basically what this means is that this actually returns the object itself, JNI object, okay? And now I can use the dot operator, new double array. New double array, the length is now. So if you're more comfortable with the dot operator, you can dereference it and get the actual object instead of the pointer, and then use the dot operator. So a star environment dereferences the pointer, returns the object itself, and then dot. So this should still work fine. So it compiles, let's copy the dynamic library, and then let's run our Java to make sure that it works fine. It does work fine. All right. So this was example 1, where we pass some primitives to C++, and C++ returns a primitive array back. Now let's do the opposite. Native, let's say double func1 double array x. Okay, so basically here I'm passing a primitive Java array type double to C++, and let's say I wanted to bring back a double array. I mean, if it's primitive, again, it's easy, but okay, maybe let's start with the primitive. So I select the Java file and run the Java H tool to update the header file, and then copy and paste this declaration to my CPP, the compilation unit. And then again, the signature is double array, square bracket double, and then it returns a double. So now here we have J double array, and again this J double array is an object in C++. If it's C, if you're not using C++, you're using C, it becomes a struct data type. If you're using C++, it becomes a class. It's an object class. So let's call this again environment, env. J object is test primitive array, and then J array x array. Let's call, or x, something that reminds you this x is a Java type, right? Not a C++ type. And maybe okay, let's say that this function is actually adding up the elements in this Java array. So it's a summation. So what do I need? I need to, or maybe let's do this. Let's create a C array or C++ array first, and then copy the Java array to C++ array, Java array to C++ array, and then perform the operation on C++ array, and then return the result. Now the reason I'm doing this, even if this function is doing a simple sum, is that you might be using some library in C++ that has this function sum, but it expects to take a C++ array. So you have to go through this conversion. So J double, let's call this C array, but we have to specify the length here, right? So how do we do that? I have to first get the length of this double array. And in order to get the length of Java array, you probably guess what we need to do. We have to call this environment object, which is our JVM. So we ask JVM, hey JVM, what is the size of this array? So JInt length or len is environment, the arrow operator, get array length, and pass in our J array. Okay, so J double array is a subtype of J array, and this function takes a J array, and J array is a subtype of J object. So we always, if we want to have some information about the Java object, we ask our JVM or this environment. So I'm saying that, hey JVM, what is the size of this array? Obviously, this is equivalent of saying in Java, say that x dot length, right? Because JVM knows the length of this array in Java. And now we have this C array, and what I can do, I can, because what I need to do here, I need to copy this Java array to this C array. And again, all the elements are this Java array are known to the JVM. So I ask JVM. So environment get double array region, and I tell it, okay, take this Java array from index 0 by this number of elements and copy them or put them in this C array. Okay. And if you look at the signature of this, this C array is specified by double pointer or J double pointer. Again, this is another reason I always prefer to use with the JNI defined types. So I could use double C array, which is a raw C++ type, but I prefer to use the JNI type, J double, which doesn't really matter that much because J double is a type def of double. So it's just alias for double. So basically JVM takes this double array, which is this C array, remember, is a pointer, is a double pointer to the beginning of this array. All right. And then I need to tell the length. So let's just set the length to, because we already know the length of this C array. So we set the length, we copy them, and then we want to perform some operation on this C array. So let's say J double sum equals 0, and then for int I equals 0, I less than len I plus plus, I'm going to say sum plus equal. And again, very familiar syntax to Java because the basic syntax of C++ and Java is the same. C array at index I, and then we are returning a J double. This sum is a J double, return sum. All right. So this is how we convert a Java array to a C++ array and copy all the elements over to the C++ array, and then we perform some operation on this C++ array and then return the result. So let's compile. Compiles fine. Let's copy back the result. Okay, and again, to reiterate, anything that I mentioned here about the double arrays, it also applies to int arrays, other primitive types. So I guess double, most likely in scientific computing we always use doubles, so that's why I'm focusing on doubles, but any other primitive type also works here. So let's say we create this result, and then double sum is test.func, and we pass in our result. So I use my C++ code to create this double array in Java, and then I use my C++ code to create to basically calculate the sum of these all elements in C++, and then return the result back to Java. So sysout sum 12.5, right? And 3.75 plus 1.25 is 5, and 10 plus 2.5 is 12.5. So this works fine. So this was number 2, create basically copy Java array into C++ array, and then return a result. Now obviously the next one is the most complicated one, is to have a Java array and return a Java array, and Java doesn't allow me to do this because this is not a valid overloading, so I renamed the function or method to something else. So this is the most complicated one, and if I select the Java file and run the Java Edge tool, and it updates the header file with this new method, and then I copy and paste it in my CPP, the compilation unit file, and then I add the implementation, JObject and JDoubleArrayX. So here, let's say we want to take this Java array and multiply all the elements by 2. All the elements by 2. So the same routine, we have to take the length first. Int len is environment get array length, and then pass in a J array, which is a J double array in this case, and then create a C++ array, and then so J double C array with the size of length, and then copy elements. So environment get double array region. So we're getting the memory values, the array in the memory from JVM to C++. That's why we use get. When you said get, because we're asking this environment or JVM, saying that, okay, get those, put them in this C array. So J double array is X from start index 0 with the length of len, and copy them in the C array. And then we're going to perform operation. And the operation is for int I equals 0, I less than len I plus plus, and let's make a change and use the pointer notation. So C array is a pointer, and I can increment the pointer 8 byte because it knows the type is double, so it goes up 8 bytes. So if I add 1, it increments the pointer by 8 bytes. And then I dereference it to get the memory value, not the memory address, and then basically multiply equal by 2. Okay, and then the return the Java array. So I have to create a new J double array, basically y environment new double array. So I'm asking the JVM to create a new double array for me, and then ask the JVM to copy the elements over from C array to Java array. So set double array region. So J array is y, set double array region y from start index 0 with the length of n, C array, and then return y. So I take a double array, I have to copy it into a C array to be able to perform my operations, and then create a new double array and then fill it up with the results of the operations. So let's compile this. Compiles fine. Let's copy and paste it into our Java project, and then go to our Java project. So double result 2 is func2 result. So I use my linspace to basically test.func2 to create an array, and I sum it up, and now I multiply it by 2. Again, sysout arrays to a string, and then result 2. So I expect each element in this result array to be multiplied by 2. 0, 0, 1.25 becomes 2.5, 2.5 becomes 5, 3.75 becomes 7.5, and 5 becomes 10. So it works fine. So I hope you understand how to work with primitive arrays. So please stay tuned, and I'll see you in the next one.